Hi students, welcome to HSC Earth and Environmental Science and Module 5, Earth's Processes. This is video number 15. We're going to have a little revisit on the evolution of the Cambrian fauna. So this is the last, it's the penultimate video in this particular module. And in these last two little videos, we're going to be looking at how principles like uniformitarianism and superposition, fossils and absolute dating can be used to help date events of geological significance. And we're going to look at two of those, mass extinctions and the subject of this video, the evolution of the Cambrian fauna. So as usual, we try and set you up with three levels of success. So initially our entry level is to try and contrast the principles of uniformitarianism and superposition, and hopefully they're going to come through from your Year 11 course. Then we want to apply these principles in the context of the Cambrian fauna, add in a little bit of absolute dating so we've got both relative and absolute forms, and finally to see if we can delve a little deeper and discuss the evolution of the Cambrian fauna using a range of different types of dating methods. Now this is such an interesting period of geological history that it's definitely worth spending a little bit of time looking at it. It's one of what we describe as the key evolutionary events. We will look at some of the mass extinction events, and they too were very important evolutionary events. But this is really the point where we had a mass speciation event that seemed to happen almost instantaneously in terms of the fossil record. Now, it wasn't like that, but that's the information that we can gain from the fossil record. And so we want to try and have a look at some of the key events, some of the key tools that we use in order to help give us an idea about the age of this particular event and some of maybe the processes that were occurring at the time. One of the things, I guess, that made this so significant was this proliferation of complex life. So we had what seemed to be hunters, we had organisms with distinct head regions, with eyes, with teeth, with jaws, with exoskeletons, some of which were a much better candidates for fossilization than the soft bodies of the Ediacaran fauna. But also, some of the developments of these particular structures would also have assisted the organisms not only to be hunters, but also to be prey trying to escape from a predator. So there was really an evolutionary arms race, if you like, that was happening at this period of time. Lots of selective pressures, which is one of our key drivers of natural selection, is the selective pressure on different individuals within a population to select those who show the greatest adaptation or who have, through variation, gained some sort of an advantage in a particular environment. And this was a very rapidly changing environment. So therefore, we can expect that there was a kind of a rapid response from these different organisms. So how do we age geologically significant events? What sort of tools do we now have that we can use in order to age something like the Cambrian explosion? Well, what I've done is I've put some of these key strategies in a table and tried to draw some of these at least draw some of the relevance between these particular principles and what we saw happening in the Cambrian. Now, of course, this is by no means an exhaustive list. It's really just a starting point for you. And what I want you to do is, with some of the material that you'll see in class, some of the stuff that you'll look for yourself, some of your own general knowledge, perhaps you'll be able to expand on these a little bit. But at least this gives you a bit of a starting point. So we have to talk about the principle of uniformitarianism. And of course, the key part of this word is uniform. Things that are uniform are similar, they're the same. And in fact, part of what we look at now is the present being the key to the past. So what we see happening now, the observable natural processes that are present in the world now in relation to earth building, crustal destruction, formation of new sedimentary rock, the preservation of fossils, all of these are very slow, steady processes, and we see them in the present, and we extrapolate that they were doing the same sort of thing at the same sort of rate back in the past. These changes very gradual and very rare, but occasionally we see some very significant events, some significant change away from that gradual process that jumps out at us and it makes us sort of think, is this contradicting the principle of uniformitarianism, or is it consistent with what we think about what's happened in the present being a key to what's happened in the past? Superposition, of course, is very important as a relative dating tool because it allows us to talk about rocks in a sequence. So we talk about layers of rock. We've talked about the fact that the older layers sit below the younger layers. And so therefore, when we find rocks that have fossils that tell us that we're looking at Cambrian age rocks, we get a sense of what other fossils are found in rocks above those, and we get a sense of what sort of fossils are found in rocks below those. And so that gives us an opportunity to start looking at not just superposition within a column, but also at stratigraphic correlation, the comparison between different types of places that may have similar fossils and even in some cases some similar layers that are helping us to correlate between. And that's now bringing in this principle of stratigraphy. So stratigraphy is just the study of rock layers. So when we talk about stratigraphic correlation, we're looking at two different sets of rock layers in two different places, and we're trying to match them up in some way on the basis of similarity of rock types or similarity of fossils, and hopefully both. Once we get into this idea of stratigraphy, particularly if we're looking at the fossil assemblages, then we're starting to see if there is some significant links between the fossils that we find in one place and the fossils that we find in others. Obviously, or maybe not obviously, but one of the key areas in which we know about a lot of the diversity of the Cambrian is in the Burgess Shales. But if the Burgess Shales were the only fossil site that contained Cambrian rocks and Cambrian fossils, then it would be difficult for us to sort of make any conclusions about that anywhere else. But we do find Cambrian fossils in lots of different places, and we correlate them. We look at the layers, we look at the fossils that are in the layer, and we try and work out how similar they are to others. But we also look above and below those layers. When we look below those layers, we see very few fossils, just those Ediacaran ones or nothing at all. Above them, we find diversity of life that's moved in some ways towards, and I use that word carefully, what we see today. So the evolution of different organisms becoming like the communities that we see on the planet today. And so that's what's happening in the younger rocks, the rocks that are above those of the Cambrian, and not very much below. So there does seem to be a very significant difference in the amount and diversity of fossils that we see that mark this particular period of time. We've now talked about index fossils as well, and index fossils are still about relative time, relative dating, but they're starting to get into a little closer, depending on how good they are as index fossils, to some sort of absolute dates. So we know the base of the Cambrian is really important. We find trace fossils, actually, little burrows that were made by some sort of maybe worm-like kind of a creature, soft-bodied creature. Most of what we know have come from trace fossils, not from the actual organism itself, but they seem to mark the base of the Cambrian. So once we see these little burrows, these little trace fossils, we know that we've moved from the Proterozoic through into that beginning of the Paleozoic, the start of the Cambrian. A trilobite shows us that we've moved from the early into the mid-Cambrian. So this particular trilobite is another good index fossil that tells us about where we are in the geological timescale. And as we go from the mid-Cambrian through into really the early Ordovician, we've got Billingzella, a brachiopod that is also a good marker for that particular time period. Now, they're still really relative dates. They're not giving us any absolute dates. All they're doing is indicating that these particular rocks are of this kind of an age. So if we're going to do absolute dating, then what we need to do is we need to look at a radioisotope. Again, we fall back on one of those crystals that we've looked at previously, the zircon crystals, which are really good for aging very old rocks that were laid down in layers of volcanic ash. And when we look, we can see some sequences, especially in Africa, where we found a couple of different ash layers that can be dated, and then some of these really important Cambrian fossils sitting between them. So that gives us a nice little date for the lower edge and also for the upper edge. So part of what we try and do with our dating is, if we can't date the actual rock or the fossils themselves, if we can get dates that are close by looking at the rocks above or below and use our radioactive techniques to date those rocks, then it really allows us to narrow down our potential age ranges much more accurately. So then, was this an example of punctuated equilibrium or gradualism? And we'll give you this little article to look at and read. There's some very complex stuff in here, but there's also some really interesting stuff to look at in terms of the rate of evolution. And when these guys were having a look at the Cambrian explosion and trying to explain it, what they did was they looked at a current group that are quite similar, and which they could track through in terms of both their morphological or structural features and also their molecular. So we've come a long way in being able to look at DNA and important other biomolecules to get a sense of how similar certain types of organisms are, or perhaps when mutations have occurred that have indicated some level of divergence between different groups. In studying the modern arthropods and having a look at some comparisons around morphology and molecular structure, these guys concluded that the rate of evolution for phenotype, so that is the physical expression, the morphological expression, was 4 times faster, and in terms of molecular evolution, 5.5 times faster during the Cambrian explosion than any other time after that. These rapid evolutionary rates seem to be relatively robust to the assumptions that were made in regard to precise ages of the arthropods. So whilst we can't go back and actually date the organisms themselves, we can have a little bit of a look and we can make some assumptions about similarities, again, partly based on that idea of uniformitarianism. And fastest inferred rates, though, were still consistent with evolution by natural selection and with data from living organisms. They've said that this potentially resolves Darwin's dilemma. What was Darwin's dilemma? Well, Darwin's dilemma was around the idea of punctuated equilibrium or gradualism. Darwin was very much talking about an old Earth, a long time, very gradual change happening in organisms, leading to speciation, new species developing, ultimately into new genera, families, orders, classes, and so on. When we look at the Cambrian fauna, it really looks more like punctuated equilibrium. It looks more like a period of stasis and then a boom in speciation, a huge change. And yet, when we look at some of these rates, we think there is a consistency with the idea of Darwin's natural selection. But what we do have to understand is that maybe some of the selective pressures were so significant during this time that it really fueled some of these very high rates of evolution amongst a range of different organisms, not just the arthropods. This is a kind of complex diagram that came out of this article. And I guess the most important thing about this particular one is what you can see around the time of the Cambrian explosion, and that is huge divergence. So here we have adaptive radiation. We have a lot of change, a lot of different groups heading off in all sorts of different directions. And you can see in the same way the level of molecular change that was happening when we map that, and also morphological or structural changes that were happening through that period of time. This was a massive blast of evolution, a lot of change that was happening in a very short period of time. There's too much detail here for you to try and take all of it in. By all means, have a look at some of these really important groups that we know of from very early in the fossil record, and many of whose ancestry we can trace back into the Cambrian period. So this is one of the ways that we want you to start to apply these very important principles of uniformitarianism, of superposition and stratigraphic correlation, very important index fossils, and also absolute dating, to help to give us an idea of not just the scale of this Cambrian explosion, but when it actually occurred. Well, that's been a lot for this particular video, and we have one left to look at, and that's mass extinctions, and we'll look at that in the next video. Thanks for watching.